Well, good afternoon, ladies and gentlemen. I'm Charles Conrad. I've been tasked with troubleshooting and hardware decisions. On the end, we have Nick Black, our team leader, Jose Vital, and Joshua Slanis. So our project, because a lot of musicians don't have access to lighting boards or really have the time to design their own lighting scheme easily in any venue, we've decided to help with that. With what you have commercially available now just reacts to beat, rhythm, and not really that much else. So what we've done is, through the help of the Yin algorithm, which is an algorithm that is mostly designed for speech processing, but because it doesn't have any top range, it's immediately applicable to audio devices. We've decided to use that, and it actually produces frequency and other variables in real time. So you can design your audio or your lighting scheme based on how you're playing. Our initial design is going to be a guitar overlay, and the person responsible for that is Jose Vital, and I'll let him talk about that.
So the two things that I'm actually going to briefly speak on are the guitar overlay and the user interface. The purpose of the user interface is to be a barrier between the guitar player and our components, microcontroller and so forth. It serves as a user interface in the sense that it is a guitar pedal. So depending on what mode, which Nick would speak on here shortly, the guitarist chooses their modes that control the LEDs connected to our guitar overlay. So the purpose of the guitar overlay is to, it's going to be 3D printed, it's going to be snugly fit, we are going to integrate all the LEDs on there that are going to go based off of each mode chosen by the guitarist. They're both going to be connected, or I guess the guitar and the overlay are going to be connected to the user interface. And it's basically, like I mentioned, depending on what mode the guitarist chooses, it's going to determine what pattern you see on the actual guitar, and as the DMX light that we're going to integrate into the project. So Joshua's going to speak on PCB design.
So, my name's Josh, and I've helped out with the hardware, and also I'm the lead designer for the PCB. The component and circuit that we use is the TeamC 3.6. The TeamC has a 32-bit, 180 megahertz ARM processor, which has a high level of computational power than what an Arduino would give us. After figuring out, getting the TeamC, getting the pins correct, we noticed that there were a lot of components and pins that we actually didn't need. And so to continue to challenge ourselves through the project, we are actually kind of designing our own TeamC circuit board, reducing the components and reducing the pins, and while still maintaining the processor of the ARM. And next we have Nick, he's going to talk about the different modes.
So we have 5 modes planned for our audio LED display. The first mode is frequency mode. We have a pattern mode, amplitude, static, and tuning. The frequency mode uses the Yin algorithm to determine the notes played. The amplitude mode is based on the peak-to-peak voltages of the incoming signal, and the pattern mode is based on the player's rhythm. Our user interface is designed as a traditional guitar pedal, so you can use it in series with other effect pedals. The project also has the potential to be used as a DMX controller, which is a standard used in standard for a protocol for stage lighting. And we've successfully built prototypes for the frequency mode, amplitude mode, and tuning mode, and it can be demonstrated at our table. So we'll now take questions.
Guitar overlay, are you picking, I guess, a particular shape? Does that affect the acoustics or the playability of the device, the instrument itself?
Sure. We can make the overlay for any kind of guitar. We're originally going to use this one because we can get the most LEDs on it for the most effect. Some other guitars, they have a pick guard on them, so it's a little bit easier for this guitar since it doesn't have that. It's very easy to get it to mount on there, and then we can just have like the more LEDs, and we get the better effect for it. But it can be designed modularly for any guitar, though.
So where is the PCB? Is it in the guitar overlay or it's in the?
It's going to be
user?
And the user interface is actually, we're gonna slot it in there, depending on how big we are to design it, because he is gonna integrate a couple more components to it. So it's actually gonna fit in there, and we're gonna design a little stand for it where it can sit.
Okay, so you might consider why you want to build your own PCB, because that's going to add quite a bit of complexity, and and Teensy is quite small.
And you're suggesting to use this available?
Yeah, use available hardware.
Yes, but they need the experience of
Okay,
this.
So I don't know, maybe that's.
One follow-up question, have you validated that you will be able to control DMX lighting? Do you have a DMX protocol box?
Well, we currently have a DMX light that we can control, so we're currently looking into the coding for that one. We just got the light in a couple weeks ago, so we're trying to figure out exactly how we need to like address that one, and then get the actual the shield to connect between the interface, like our right now it's our Teensy, to connect like using it's a RS 485, so the protocol to connect back and forth to the actual DMX controller.
Okay.
So you have
One
five
last-
different modes or something like that. Most people play guitars and they would probably want this as are very artistic in nature and don't want to be a copycat to somebody else, and
Right.
only having 5 different selections feels like that may be a little limiting for that group. Is there some way to make this even more user defined or?
So the frequency mode, we've mapped it to 50 different chords and notes. So if you play a different song, it's going to show a different pattern each time you play something else. So if somebody plays one song and another person plays another thing, it's going to show a completely different line pattern.
And while none of us are CS, there is the possibility of creating a user interface where they could design their own patterns that they would do, how the colors and other patterns that they want to show up whenever they play.
Any of you musicians in
We are.
Right. Maybe the last one, we're running late.
Could you use this as a tachometer? I mean, could you set it to, like for an engine or something, where you could set it to a specific frequency and it would change the color?
Because the yin algorithm is very accurate, all of the research that I found on the yin algorithm were specific to voice. So yeah, having like a microphone set up, the gross error rate for the yin algorithm using voice was 1.02%, I believe.
Sure.
So it's a very small error. And just in our own work, you're within 0.01% of whatever you're looking at. So the yin algorithm itself could be used for tachometer.
All right, let's thank the team.